Okay, so in this example, we have an application where it says create a quadratic model that represents the relationship between a person's age in years and the average hours spent exercising. Is there a point at which they max out? So if you look at the x values, we're increasing in age from 15 to 24. And we can kind of see the quadratic shape for our y values. We start at 3, go to 4.9, hit 5.4, and then we start to decrease as we get older. So it kind of makes sense, physically, when we're younger, we exercise more. As we get older, it's a little bit more challenging, whether you have children, work, or old age kind of sets in. But you can see here that it looks like at around age 24, given the data, 5.4 is our max. We can't say that that's our solution because we don't know 100% that that's the peak of the hours spent along with the peak age, if you will. So we have to create a quadratic model to determine where that peak is. It could be age 24, but it might be something different. And potentially it's going to be around this, give or take a few years. And then secondly, it's going to ask what's going to happen at age 43. So we need to predict what happens at age 43. We need the model in order to do that. So the first thing I'm going to do, just like in all our other videos, is I'm going to hit stat, I'm going to go to edit, and I'm going to start entering my information. So 15, 20, these are all my ages, are all my x values. Okay, so I have all my x values in list 1, list 2. I have 3, 4.9. Make sure your decimals are entered correctly. If you put in 49 versus 4.9, it's going to completely throw off your data. Your calculator is still going to spit out some sort of equation, so you assume you've done it right. So you just got to be careful with how you enter. So always good idea to double check. So if we look at our list, 15, 20, 24, 32, 40, I'm good to go. And then we look at 3, 4.9, 5.4, 3.7, and 1.8. I've entered the information correctly. So then I'm going to go to stat. Okay, and so now we go to calc. And I go to quadratic regression, which is 5. And then I have my x list in L1, y list in L2, and then I'm going to go ahead and I'm going to hit calculate. And I actually did the wrong list. I did cubic regression, so let me go ahead and go back to that. And I hit quadratic regression, x1, L1, L2, I hit calculate, and there is my quadratic. I have 0.016. So we'll go ahead and enter this. I have 0.016 x squared plus 0.827 x minus 5.449, rounding to the nearest thousandths place. So this is our actual model for our quadratic. So what would we need to do in order to find out where the max value is? So in order to do that, I need to figure out what the vertex of the parabola is. So I need to actually go ahead and graph that. Okay, so now we have our function written down. You can either input this directly into your calculator and graph it. There is functionality which allows me to automatically place it into my graphing portion. We're going to go ahead and do that. So just to repeat the process that we went through last time, I would select quadratic regression, but on this spot that says store reg eq, that's the regression equation. I hit the vars button, V-A-R-S. I'm going to select y vars because those are my y functions. Select functions, and the very first one is y1. So now when I calculate this, what's going to happen is it's going to auto-populate this equation in our y equals. So that's now in our y equals. And what this is going to allow us to do is we want to know what the max is. So I need the vertex. So I'm going to graph this. And I need to see a lot more of the shape. So it's a little bit of guess and check. So I'm going to go ahead and I'm going to zoom out. So if I hit zoom, my third option is out. And I hit enter again. And gives me a little bit of a better picture. So I'm actually seeing the max of the parabola right here. Okay, it's not the best picture, but I know where it's at, and I can use the calculator function to actually just tell me what it is. So we've done this before. So to find the max value, I hit second, calc, go to maximum, left bound. This is to the left, so I'm going to hit enter. Now right bound, I'm going to move the cursor all the way to the right of the maximum. Just going to make sure I'm on the other side. Hit enter, enter again. And so now I know my max is at the coordinate of 25.3, 5.05. And so as we can see here, we have our max value is 25.3 for age and 5.05 for hours exercised. We notice here that 5.4 is the max. It's larger than the 5.05. And what's happening here is we have a model that is fitting these data points, but it's not an exact fit. So it's a good approximation. There's another number that comes up. It kind of tells you in some calculators, depending on what you see, it's basically the correlation coefficient, for lack of a better term, and it tells us how strongly related the data set is with our equation. And this one was close to 1, but it was not exactly 1. And that's why we're seeing a slight variation in values. The next thing is, how will we predict what happens at age 43? So at age 43, I can actually use my calculator for this. The equation's already plugged in. So if we go to second, calc, we go to value, well, x is our age, so I'm going to plug in 43, and it's going to give me a negative value. Once again, this is a model. But basically, based on this model, at age 43, it's telling us we're going to exercise negative hours. So the mathematical equation has no idea that this is about people working out. It's just giving you the pure numbers and what's going to happen. So, but basically, we can interpret that at age 43, people stop to exercise, which we know is false. But definitely at age 43 versus age 15, 20, we are going to be exercising less. So the numbers, even though they are correct, may not necessarily fit exactly what's happening, but it gives us an idea of saying, hey, look, based on our data, people exercise the majority more hours when they're around 25 to 24 years old. Okay, so this is how we can use a model to look for future information, which is age 43, or determine max information. So for example, age where we're exercising the most.